Hello and welcome to Functional Reactive with Core Java. My name is Sven Ruppert and I'm developer advocate for JFrog, and you are here because you clicked on my video about Functional Reactive, and this is the first part of the series, the introduction. I will give you the link below in the or down in the description, so you can start with this one. If this is the first video you see, then you see what is part of the series, what is planned, and why I'm doing all this stuff. Here I'm now talking about the basics of functional interfaces, what we can do, why we can do this, and so on. I would really appreciate if you subscribe my channel, and if you have German speaking colleagues, just check out, I have a German YouTube channel as well, and you can go there and you will find the same video there as well. So what we want to do today, functional interfaces. And before I'm talking about functional interfaces, I will have just a few words about what the difference between object-oriented and functional in Java. So Java is an object-oriented language for sure, and with Java 8 we got a lot of syntactical stuff. And now is the question, is this now functional if I'm using this one? For example, here I'm using optional. This is a new class since Java 8. We will go to the optional in a later part of this series, so don't be scared of this one here right now. But think about the optional is something like a holder, and we have now a holder of type string, and I can invoke a method like .map, and then I'm giving here a method reference or some anonymous classes, whatever. So the main thing is this now functional because I'm using here this method references? No. Is this functional because I have a holder and I'm invoking a method on this? No, not really. It's like a regular class, huh? So the same is if present, if something here do something with, so I'm injecting some transformation logic. Is this now functional? Yeah, maybe, but it has nothing to do with the syntactical thing that I'm using method references here. Another way is this strictly object-oriented if I'm just removing this method reference and using on-the-fly implemented class of type consumer, like I've done it before Java 8 in Swing, for example. Well, you can code functional in Java even before Java 8. It's the same stuff you should have in mind and how to compose all this stuff. It's not so nice. It means with Java 8 we have a bunch of syntactical stuff, but it is an object-oriented language. So even if we have this or else throw or whatever, so it doesn't matter if this is a special name of this method or whatever, it's some typical stuff that makes it more functional, like immutability and composing in functions and transformations. So the border between object-oriented and functional is in Java not really very sharp. It's sometimes a little bit more object-oriented, a little bit more functional, and quite often it's not bad if you're mixing both approach to get the most elegant code out of it. So, but we got functional interfaces. What can we do with this and how this looks like? A functional interface is an interface that has only one method to implement. You can add this annotation at functional interface, but this is just that to make sure that the compiler will check if there's only one method that you must implement, otherwise the compiler will break. From the functionality point of view, there is no difference. So there is no difference between an interface with one method signature with this annotation or without this annotation. It's just the same. So I think even in bytecode. So this is the main thing, just one method to implement, then it's a functional interface. So all action listeners from Swing, from the old days, are functional interfaces. On the other side, you have now the possibility to get a default implementation. So if you have a method definition and you add this keyword default, then you can add the implementation itself. It's a stateless implementation because you don't have attributes on interface. Don't do this with static attributes. Don't do this one. So I see quite often, yeah, I declare a static hash map and then I'm working on it. Don't do it. So even with this default implementation, you have just one method that must be implemented. The other could be implemented, and this means it is a functional interface. So the next thing is, after I think JDK 9 or 10, I'm not sure, I have to check, but after JDK 8 or Java 8, you got the possibility to add private methods to interfaces as well, because the default implementation shows that you have this long and repetitive implementations of this default implementation, and so people ask for something nicer so that you can divide your implementation as you have done it before, and this means you got this private implementation. It could be just a private one. You don't have to use the default keyword, and you can't just declare the method. You really have to provide an implementation. That's it. So you have functional interfaces with or without this annotation. If it is just one method that you must implement, with a bunch of default implementations if you like, and some private implementations if you want. So, to show you a little bit what this has to do, or how this looks like if you're dealing with inheritance, because Java is an object-oriented language, means you have inheritance, and the same with functional interfaces. There is inheritance. So I have an interface A, and then from this I inherit an interface B, and then I have this class A, and this inherits from or implements interface A and B. And at the same time, I have a class B that's implementing interface A and the completely different interface C. It's not inside the inheritance tree of A and B of these interfaces. How the interface looks like. Interface A has one static method called doStaticWork, and it has one default implementation, doWork. So it's not a functional interface, by the way. So the next one, interface B, this one is extending interface A and has a default implementation for the same method signature, doWork. So I have now in A a doWork method and in B a doWork method. And then I have interface C, not inside the inheritance tree, but has a method doWork as well with a default implementation. So what happened if we are mixing up this stuff now? So class AB is just implementing A and B. You don't have to do something, so everything is fine, because the compiler can decide what is the actual and the active implementation. And the rule is, if you are in inheritance tree or line, the most specific implementation of default implementations will be the winner. Means B is A has an implementation, but B has a more special one, because B is inheriting from A, means the default implementation from B is a winning implementation. The compiler can decide. Other way around, it's with class AC. I have now interface A with this default method and interface C with the same default implementation, and the compiler can't decide which one is a winning one. So the compiler will break the build or the compile and will say, you have to make a decision, you have to implement this by yourself. So if you're now using this stuff, class AB, you can just create an instance and invoke the method doWork, and the result is from B. But you can't, just as a reminder, you can't invoke the static method from interface A. And this means later we are searching for places where we can add factories for functions and all this stuff, and static methods in interface are a good place. But if you're designing this one, have in mind that if someone that wants to use this one has to know that this interface is somewhere, so you're giving information free from the inheritance tree itself. So be aware of this one. And class AC doWork, well, we implemented this method by ourselves. This is just fine. So, but there is one other thing that is really a beast. I will show what I mean. So the demo functional interface, or the demo functional class or a class, has one method, a static method called doStaticWork, no input parents, but the string is a return value. And then there is a functional interface called interface A, and it has a method doWork, string as result, no input values. If I'm using this one, for example, in class, here it's called demo class, and I have a method, and the parent will be an instance of interface A. What can I do? The first thing is I can just create this demo class, and at the time I'm invoking consume interface A, I'm just implementing it on the fly, like I've done it before Java 8. This is all fine. If I now want to use these lambda expressions, I can do the same with the lambda expression, for example here with this lambda construct with a thing and with a, how it's called, I don't know. So this is, it doesn't matter if you take the long syntactical version or the short syntactical version, it's just a lambda construct. We will have this one in more detail, how you can do this one and to reduce the syntax. But one thing is tricky here. Check the last line. If you're using the method reference from the static method that is somewhere, not even in the same interface, this is possible to use this one as well. Why? Because the IDE will show you it is possible, and refactoring toolings will give you this as a possible thing, but you want to have an interface A, but now you're using a method reference to a completely different method. Method handles are a little bit weak with typing. It means the method do static work has a name, no params, and string as return. And the do work method has exactly the same, no params and a string as return. And the basic thing with method handles is, or method reference is that it's just the return type, whatever name, and then the sum of attributes. And here both are matching. No attributes here as input, but both giving back a string. And so this fits. And this, it's good if you have this one in mind, just to make sure that you're not mixing up method references with things you don't want to have. Okay, so this is the basic stuff about functional interfaces, just to have a warm-up and just to play a little bit around with the syntactical stuff. We will go to all this stuff more in detail over the time. And the next thing is, the next part of the series is about optionals and the corresponding better or advanced implementation called result. By the way, if you want to have this demo code and if you want to have all these patterns I will show you here, in Java, there is a GitHub repository called functional-reactive-lib. The link will be down in the description. So there you can find all the stuff I'm explaining here already in code, and you can try this directly by yourself. Then that's it for the first part here. If you have some recommendations or if you have some special ideas or feedback, just write it down in the comments. I would really appreciate if I would get a thumbs up, and subscribe my channel please with a bell so that you get informed if I have the next part. So yeah, then enjoy, and I see you in the next part. See you. Today we want to see how to create your own test engine for JUnit 5. That means in the beginning we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need Debian repositories, what's influence and what part of your infrastructure is. The next thing is why you should have an eye on it. What will this series about? It will be about functional reactive, and this for core Java.